Welcome everyone to our fourth webinar for Finding Dory. For those who have joined the group recently, we are an ad hoc group of cruisers. We're either an ad hoc group of cruisers or a group of ad hoc cruisers planning to cross the Atlantic this season. We organize our Finding Dory flotilla as a group of people who want to cross who normally are not planning to cross with the organized flotilla. So we have a community to mutually support each other. And part of this support is the webinars that we're organizing. This is our fourth webinar, and I'm super stoked to have Julia Andrews with us. Julia will introduce herself. But before I give the microphone over to Julia, I just wanted to remind everyone, keep yourselves muted during the first part of this webinar, which is the presentation part. So there, the podium is all for Julia. And then we will follow with 30 minutes of questions and answers. During the webinar, you can put already questions and remarks and suggestions in the chat box on Zoom. So after the presentation part of the webinar, we go through the questions and we leave the room open for any questions that might pop up or follow-up questions, follow-up remarks on the topic for today. We're supported behind the scenes by my old friend and ex-colleague Sami Alio, who joins us from Damascus in Syria at the moment. And I see there's a quite nice group of sailors in our group have joining us today. So this webinar is recorded, and I'll share the link to the recording after the webinar, after this processed. Julia, it's all over to you. I'm going in mute, and the podium is yours, Julia. Thanks again for joining us, and all yours.
Thanks, Peter. Assuming you guys can hear me. Thanks for having me. Just going to spend the next hour talking to you guys about something I love, the weather. So I hope you get something from it. Okay, here we go. Okay, so a little bit about me. I am a researcher in weather and climate science. This is what I have been doing since about 2011. Probably more about me, well, what's taken up more of my life is I'm a full-time liveaboard cruiser since 2016. Most of that time was on a 44-foot monohull. And we've done that sailing with our three kids who are 7, 9, and 12 when we started sailing. So far, 25 countries, 25,000 nautical miles, which is a single Atlantic crossing, which was Gran Canaria to Barbados. I think you saw the picture of our crossing on the previous slide. We did that. We started in 2019 and arrived in Barbados early January 2020. And I still get seasick. Now, why am I telling you these things about me? Predominantly because obviously I'm going to give you some weather advice for the next hour. And I think it's probably good that you know who I am, where I come from, and it gives you a little bit of indication as far as what sort of weather advice you're going to get from me. Now, the fact that I sail with kids, the fact that I sail on a fairly small boat and I get seasick is probably going to give you an indication that my advice is not going to win you any races necessarily. But, you know, I certainly have a focus on, you know, safety and comfort and things like that. So that just gives you a bit of context for the advice I'm going to give you. Okay, so what am I covering? First thing I'm going to just talk about is a couple of frequently asked questions that I get about the weather and just some common misconceptions about the weather and forecasting. The reason I sort of like to cover these is because obviously when I talk to sailors, I spend a lot of time talking to sailors, I get a lot of specific questions, a lot come up more than once, and in the boats that I have worked with, because I have sort of worked with a few boats, weather routing them across the Atlantic this way and back the other way. You know, questions that come up, experiences that come up. So just want to sort of cover and you know, clarify some of those things. Some of those things are probably going to be old news to you guys, but I'll cover them just in case. Okay. So first thing I just want to talk about is most of you guys are going to be accessing your weather and your information via like weather apps. You know, the most common ones of those: Predict Wind, Windy, Luck Grid. and obviously insert your favorite app there because there are a lot of them. The important thing about these weather apps, you guys probably don't do it, but I hear often people talk about the fact, oh, the windy forecast was wrong, or the predict wind forecast was wrong. And what the situation is with these apps is they are not necessarily, obviously in some cases that's not true. Predict wind has its own models, but in most cases these apps are not providing a weather forecast. What they're doing is they are providing other people's weather forecasts or other people's weather model data in an easy to use format that we can access and we can interpret ourselves. Now, as far as which app you want to use, I don't really have a preference. I mean, I do predominantly use Windy and Predict Wind. I also use, well, Windy, Predict Wind, and LuckGroup are my three favorites. But whatever model you want to use, some things that you want to be aware of and consider with your apps is you want to make sure that the app that you're using does give you fast updates on the weather. I think ECMWF, most of the common models will give you 2 to 4 updates every day. And you want to make sure that your app that you're using is giving you sort of the most up-to-date information. As I said, it's always nice having access to the most up-to-date information rather than old information. In some cases as well, some apps have model data. Some apps will say, oh, we have the Euro model, or we have this. They won't always have them at the highest resolution available. So that's something to consider when you're looking at different apps as well. But really, whatever you want to use is going to give you the information that you need. Okay, so the things that actually give you the weather information are the actual global weather models. There are a lot of them. The ones I've listed here, these are the main ones that you can access using tools like Windy and tools like Predict Wind. The question I do get asked is, what's the best model? If you have to choose one, what's the model you're going to choose? I've asterisked it there on the screen. The best model, in my opinion, is the Euro, ECMWF. All the models are very good. Every single model on that screen there, and plus any others, is going to give you pretty good information to get across the Atlantic. So you don't really need to worry about that. But if you did have to choose one, if I had to choose one, I would certainly go with the Euro. Now, the information that I've listed on the right there is the spatial resolution of these models. And the reason that I've listed that is because if you want to know which model is the best, if you have to make a choice, if new models come out, really the best information that you're going to get is the model with the highest resolution. And as you can see there, the Euro model ECMWFS gives you 9-kilometre data at a global scale, really, really high resolution data at a global level. And that is why that model is generally the best model out there. Another thing, and when we talk about one best model, I will say that really what you should be doing is you should also be looking at multiple models, especially if you're looking at forecasting when you're doing an Atlantic crossing. You'll be looking at what's happening 6-7 days, sometimes even further in advance. These models do offer you up to 2 weeks and beyond of forecast. Once you're looking past a couple of days, really what you want to be doing is you want to be looking at an ensemble of data. So you want to be looking at different models and you want to be seeing how consistent they are. If you're looking at a feature that's sort of 7 to 10 days out in the Euro model, for example, and it's different in Icon and in GFS, then you want to be a bit like, okay, maybe the models aren't agreeing. But if there's a feature or if there's something in the weather that's happening 7 to 10 days out, even longer, and you've got consistency with ECMWFS, you've got consistency with GFS, then you can be pretty confident that that event is probably going to take place. So a couple of other things I just want to talk about with these models. Because a lot of these are available in Predict Wind, and I assume that a lot of you guys will be using Predict Wind. I'm going to talk about Spire really quickly. Spire uses is a proprietary weather model, but what they do, which is pretty cool with Spire, is they take satellite data. They do signal attenuation from satellite data, and they use that to refine the weather forecasts of wind speeds at sea. Now, obviously, when you're out in the open ocean, there's very little data that you can use to validate your model. There's very little observational data that you can use to assimilate with your model. But what Spire is doing is they're using this satellite data for that purpose. And in validation studies, I think that Spire is one of the most accurate models in terms of offshore wind. So, if you are like really looking to sort of maximize your wind, you are wanting to sort of, win some races, stuff like that, or get over there really quickly, then, you might want to consider using the Spire model because it does perform quite well. The other models I'm going to just talk about really quickly are PWE and PWG. They are the Predict Wind proprietary models. PWE is initialized using ECMWFS. PWG is initialized using GFS. And these models are pretty cool because they use a stretched grid. So they have a variable resolution grid. They actually use an Australian product, an Australian weather model developed by the CSIRO to do this. And so what they do is in areas in coastal regions, they have a 1 kilometre resolution or an 8 kilometre resolution. And then in areas offshore where the resolution is not so important, and that resolution is then stretched back out to sort of 50 kilometres. So, when you're looking to do, when you're coming into areas with islands, you're like onshore, then the PWE, PWG model is an interesting one to consider because it does have that variability in the model resolution. And yeah, pretty good accuracy also. Now this slide really quickly, I was mentioning about model resolution. This is just a graphic based on my weather research that I do in Western Australia. And it's just showing you a little bit of the differences and how important the resolution of the weather model that you're looking at is. So you can see here we have rainfall data at 100 kilometres, at 20 kilometres, and down here at 5 kilometres. And you can see just the difference in the quality of that forecast. So if you're ever thinking about what's a good model to use, the Euro is obviously a good one, but really what you should try to use is the highest resolution data that you can at any point in time. I'm just going to really quickly touch on limited area models because I know that some of you are sort of still making your way down to the Canary Islands. Probably most of you are, in fact, at this time of the year. And limited area models, obviously, they are a much higher resolution than the global models we just talked about. They are shorter forecasts. But if you're doing short hops, really, really good resources to use. Obviously, they do, unfortunately, have limited benefit, really, once you get past Gibraltar. Once you get south of Gibraltar, there's not really any limited area models that you'll be able to use. But nevertheless, as you're making your way down the coast or in the Med, there are some models that you can use. I will just make a point, if you do use limited area models, try to avoid using data at these model edges. They're really, they're designed with their parameterizations and everything to sort of focus on really like the middle of the model. So you would ignore sort of the outer third of that data. So for example, this UK based model I've got here, you wouldn't want to use this like when you're going into Biscay. But yeah, limited area models, really high resolution, really good resources. Okay, so just want to talk a little bit here about sort of the origins of a lot of the grid data that we sort of now use in our like weather apps. So this output is computer generated and it doesn't really have any human review before it gets pushed out to things like Predict Wind. It gets pushed out to things like Windy. It basically, there'll be a very limited amount of QA making sure the data, the model hasn't done anything seriously wrong. And that data then goes up and people use it. Traditionally, that data was analysed by a meteorologist, interpreted. They would draw things like synoptic plots. And then we, as the consumers of like the weather forecasts, that would be what we would then use to make our decisions and what we would do. So these days, what is happening with our access to grid files and model data is this this interpretation from the meteorologist is largely a step that is getting bypassed. And this is really, really important to remember when we're interpreting model data and when you guys are interpreting model data, with your Atlantic crossing in mind. So I'm just going to talk a little bit about this as far as like, forecast interpretations here. Because, one of the things I get a lot is, the model was wrong. And yes, all models are wrong, but some models are useful. And the information I'm just trying to get across here is in terms of how we would interpret it. So what I did a couple of weeks ago is I'm just looking at this data point in the middle of the Mediterranean Sea. And you can see this is a screenshot from Windy. And this is an ECM WFS thunderstorm and rain forecast. And you can see looking at the couple of day forecast for this spot in the middle of the Mediterranean Sea, it's looking pretty nice. It's looking pretty sunny. There's no issues. Obviously, it doesn't have a very good sailing wind, but, pretty clear conditions. And there's forecasts in Italy, forecasts Corsica, Sardinia, no forecasts in the middle of the Mediterranean Sea. However, as me interpreting this forecast, if I were to be planning, say, an overnight passage from Olbia to Rome, I would be very, very nervous about making that passage because I have a thunderstorm forecast all around me. These thunderstorm forecasts that you get from weather models can have some significant errors in space and time. The thunderstorm and rainfall layer in particular is probably one of the layers that, if you're looking at a forecast a couple of days out, there can be some significant like space and time errors in them. So based on this data point, if I were to make that crossing, I would probably expect that I would encounter thunderstorms in the late afternoon. Most certainly, I would encounter some thunderstorms overnight. So I'm just trying to sort of get the point across that this forecast looks very good on face value, but if you dig a little deeper, and for example, here I'm looking at Cape, it's probably a very good example of a forecast that if you were to go out expecting the forecast conditions based on that single data point, you could probably get yourself into, well, not trouble, but, you'd probably have a fairly uncomfortable night with a lot of lightning and so forth around you. And, probably some pretty significant winds from squalls in some thunderstorms. So you can see here, that's the same data point. It has a CAPE of 3,500. Now, I think you probably are all aware of CAPE. It's convective available potential energy. So what it's not telling you is it's not telling you there's going to be a thunderstorm, but what it's telling you is it's the energy available in the atmosphere. So if there is a perturbation in the atmosphere, so if there is something which starts convection at the surface, how likely is that convection to turn into a thunderstorm or a squall? And if you have a CAPE of 3,500, it's pretty likely. Usually if you get a CAPE of about 1,000 or more, then that means that thunderstorms are quite likely. Obviously, as you get higher and higher, it means that thunderstorms do become increasingly likely if there is a perturbation. And what it does also mean is if you are going to get a thunderstorm, the intensity of that storm is probably going to increase if your CAPE is higher, because you'll have more chance for vertical development. And the more vertical development you get in a squall or a thunderstorm, the more likely you are to get things like hail, significant lightning, microbursts, and just really strong winds associated with the system. Okay, so we've talked a little bit about weather models. I just wanted to touch on some forecast resources. Obviously, you guys, when you're on land, when you're near shore, it's quite easy to get like an actual forecast from a weather forecaster. When you're out in the middle of the ocean, it is harder to get an interpreted forecast. So I just wanted to highlight some resources that I find very useful in terms of actually getting sort of, of like a meteorologist or a forecaster who's looking at data and who's providing some input. So the NOAA Ocean Prediction Center website is there. They do provide it is North Atlantic only, and its actual cutoff is Cape Verde, which is a bit unfortunate, but they actually do provide interpreted forecasts of the synoptic conditions, the wave conditions, and also the different geopotential heights for the North Atlantic, which is really useful. And then this tropical hazards outlook it gives you about a 3-week outlook for what you can expect in terms of conditions generally. And I'll show you what these look like here. So this is just an example from the Ocean Prediction Center. Sort of very traditional synoptic plot showing you the locations of the high pressure and the low pressure systems. You also can see you've got your warm fronts and cold fronts, occluded fronts, all your fronts. You've got your troughs. It also has ship observations as well. It has the locations. I took this a few weeks ago when Hurricane Erin was approaching the Caribbean islands. And you can see it has tropical waves as well. As I said, unfortunately, I don't know if you can see my mouse, but you can see that it does cut off at Cape Verde. But this level of interpreted forecast, if you guys are interested in, just getting some knowledge about like what you're seeing in windy and how that is going to look in terms of like an ocean forecast, this is a really good resource to have a look at. And the Ocean Prediction, I think they do up to 100-hour forecasts using these models. And I just find this information really, really useful to correlate back and forth with what I'm seeing in like a wind layer from a global weather model. So yeah, that's that. Okay, now what is this? Oh, this is the tropical hazards outlook. So this is your Atlantic region here. So this is a global outlook. And unfortunately, the screen grab that I've got here is from this last week. So this is very much right in the middle of the hurricane season. So not super useful in terms of the conditions that you guys will be expecting when you're doing your Atlantic crossing. But this data is produced every week, and it gives you a snapshot for 2 weeks in advance. So you get like a 3-week forecast, and it's just giving you what are the likelihoods of certain tropical weather conditions in the open ocean. Um, Obviously, when you guys are doing your crossings sort of from November through February, March, April, I'm not sure what your timings are. The tropical cyclone formation is going to be happening in the Pacific and here in Australia, so it's not going to be relevant to you. But the rainfall data is going to be really interesting, whether you got above average or below average rainfall. It'll help to give you a good picture about like what you can expect in terms of squall activity and things like that, because they're really the things that, yeah, it's just a good resource for 21 days in advance, that you can sort of have a bit of confidence as far as what can you expect. Because I think, yeah, if you did what we did, which was setting off from Canaries down to Barbados, it can be anything up to like I think 28 days or something like that. But very much outside the realms of what you're going to get from any forecast. So I find this tropical hazards outlook really useful information. Okay, so what are we looking at now? Local influences on the weather. I've just got some gratuitous pictures. I like taking pictures of clouds and weather. This picture doesn't really have any relevance to local influences, but I just like the picture. So sorry about that. Okay, so what I want to talk about here is, again, probably a limitation of weather models, especially global weather models. They're really good at continental land masses. They're really good like at the open ocean. But when you get areas where there are small island chains in the middle of an ocean, you get very significant impacts on weather from these islands. And these are not always very well represented in weather models, because the weather models at the resolutions, even ECM at its 9-kilometer resolution, it just doesn't have the ability to accurately capture these local influences. So what we're looking at here, these are both from the Canary Islands. I'm not sure which date, but these are layers from the windy model. And you can see GFS at 22 kilometers. There's not really any acceleration zones going on at all. And you can see in ECMWFS, you have a pretty significant acceleration zone going on between Tenerife and Gran Canary. And you also have this one here between can't remember the name of that island, sorry, and Gran Canary. Now, if you guys think about how you experience the weather, and I'm not sure if you've been to the Canary Islands, obviously Gran Canary it's a big volcano. If you think about the weather from where you are now versus 9 kilometers down the road, or like 9 kilometers up a volcano, for example, at that scale, 9 kilometers, even though it's a very good resolution for a model, at that scale, like 9 kilometers, the weather can be vastly different when you have areas of complicated terrain. And here in the Canary Islands, and also down in Cape Verde, you have situations where you have like a vast swathe of ocean, and then you have a volcano, and you have these influences which are not captured by the model. So here you can see, if you were to be taking off on this day, oh look, there's going to be a pretty gnarly acceleration zone as I leave Gran Canary. You can safely assume that the Euro model, even though it's probably the best model you have, you can safely assume that it's probably going to underestimate the scope of what you're seeing here, because even at 9 kilometers, a very good resolution for a model, it is not going to accurately represent what you're seeing from local influences. So when you see these local influences in the model, you just need to be aware that if it's saying you're going to get 30 knots, don't be surprised if you get more than that. It's all about how you interpret that data. And I have not been to the Cape Verdes, but the same thing that you will see here, you'll get. So, you'll get areas of very strong wind, you'll get areas of no wind. It's just something to be aware of, that even though you are doing ocean transits, you will also experience these situations as you go to the islands where you're going to get the weather models doing things that, yeah. So, and islands in the middles of oceans are certain areas where the global models sort of do tend to have some issues with getting the forecasts correct. So something to bear in mind. Okay, so going to talk about sea state and significant wave height. I think you remember from the beginning, I get seasick. So, this is like quite an important area for me. And these are some pictures that we took. We had a buddy boat when we did our Atlantic crossing. So these are just some pictures that we took of our buddy boat. And I'm sure you guys will do it as well. You'll spend a lot of time trying to take pictures of the waves because some of them can be really big. And then you take the pictures and they don't look that big. But anyway, yes, talking about waves. Okay, so significant wave height. What does that mean when you see that on a forecast? So the significant wave height is the average of the highest 1/3 of waves measured from trough to crest. So in case you're wondering, that's what it means. It is a trough to crest measurement. And what they do is they don't just take the average, it's the highest 1/3. So what you're trying to get an estimate of is like, what waves can you expect? Not, so yeah, but that's the definition. That all the forecasts and every single piece of information that you're looking at, that's what your significant wave height is going to be. So what does that mean? So what it means is that most of the waves you're going to experience are going to be less than the significant wave height. Say, for example, let's work with a significant wave height of 2 meters. So most of the waves you're going to get are going to be less than that. 1 in 10 will be larger than that. 1 in 100 is going to be 1.5 times that. So if your significant wave height is 2 meters, 1 in 100 waves is going to be a 3-meter wave. And 1 in 1,000 is going to be basically double that. So 1 in 1,000 waves is going to be a 4-meter wave height. And you're going to get a lot of waves. So we're assuming here, a 7 to 10 second period. That's 10,000 waves a day. So you're going to get a lot of waves. And as I said, if you're seasick like me and if you're in a monohull, then, that's a lot of movement. In my opinion, sea state is probably the most important determinant of like your comfort on passage. The boats are going to do a lot of rocking around, a lot of movement. So where your boat is going to sit in relation to or the wind direction and where the waves are coming from, it's sort of quite an important consideration. What I've just done here is because obviously you're not just going to get a single wave. You're going to get waves from sort of different swell patterns and so forth. So here, this is again just a snapshot I took a couple of weeks ago. You've got your wind wave coming in the direction of the trade winds, pretty straightforward. You have a swell coming from the North Atlantic, and you also have a swell coming from the South Atlantic. So your significant wave height takes into consideration all of the different waves that you're experiencing, but the period forecast that you're going to get and the direction forecast you're going to get, those two are just going to be based on the highest energy wave that you get at that point. So usually that is going to be on your Atlantic crossing, assuming you've got a decent amount of wind. Usually that's going to be your wind wave that's sort of pushing in the same direction as the wind, but not necessarily all the time. If there is a large North Atlantic storm, and if you're taking a fairly northerly track, then there is a chance that a swell from the north could be your like dominant wave, and that would adjust how the period forecast and direction forecast change. But it's just something to bear in mind when you do look at a wave forecast, how that data changes. So I do always like looking at this layer in windy, which gives you the ability to sort of get the breakdown of where the different waves you're experiencing come from. And obviously in this situation, what it does mean is if you have 3 different swells from 3 different directions, is, the sea state can sometimes be a bit confused. So that's also something to bear in mind. Okay. I was going to have a quick drink, excuse me, and I'll talk to you a little bit about clouds. Now, like waves, when you're on your Atlantic crossing, you're going to see a lot of clouds. I like taking pictures of clouds, but they can also give you clues and information as opposed in terms of the weather that you're going to have. I mean, you're going to be out in the middle of the ocean. As I said, you want to use all the clues that you have available to sort of as far as what's coming up and what you can expect, because there's not really much in terms of an interpreted forecast and people that you can ask about what's coming. Okay, so this is mostly what you're going to see. This is just a cumulus cloud. These are just cumulus clouds that are wider than they are tall. They'll just scud along in the same direction as you. They're an indicator of fine conditions. They're not going to have any influence on your weather. Probably not even going to provide very much shade. And you'll see a lot of these. These will sort of be probably your constant companion as you cross the Atlantic. As the cumulus clouds, and this usually happens sort of during the day, as the temperatures, as the air temperatures increase, you'll start to see a cumulus mediocris, which is a cloud that is as tall as it is wide. Again, these don't really, they're not really going to have any significant impacts on your weather or your wind speeds or anything like that. But as they start to build, it just gives you an indication of what's going on. There's more convection. There's, if you start getting the development into a cumulus mediocris sort of really early in the day, it's giving you a bit of indication that, there's a bit of instability in the atmosphere and probably something to pay attention to. I'm just highlighting this picture. Again, this is a cumulus mediocris / cumulus congestus, but you can see that there are more of them spatially. There's less sunshine between them. And this is taken on our Atlantic crossing. And you can see the sun is getting ready to set, and we've got quite a lot of clouds. The reason I wanted to show you this picture in particular is because what this means is you're going to get squalls. Squalls are more frequent at night in the Atlantic. So looking at this was a pretty good indication to us that we needed to sort of take some sail area in. And yes, we did get a lot of squalls that night. So just something to be aware of. If you do sort of start to see that cloud pattern like that, as you're getting into the evening, then you can expect to see, some squall action overnight. Okay, so I think I just talked about that mediocris cloud getting towards a cumulus congestus. So a cumulus congestus is when the cloud is taller than it is wide. Now, when you start getting to a cloud like this, these are probably going to start having some straight line winds associated with them. So some squall action, I suppose, is a good way to describe that. Not always, but as they do start to get sort of some vertical development like that, then, you probably can expect that at some stage they're probably going to start raining soon. And again, you are going to see some influences in terms of it's either going to take your wind or it's going to add to your wind. And it's probably, once you get to a cumulus congestus, you're probably going to get to some sort of squall in the near future. So again, this is, once the cloud starts raining, it becomes a cumulonimbus. That's really the only distinction. So you have this one here, which is, I'll go back to this one, sorry. This one's got fairly limited vertical development. So generally speaking, what you'll see here is not a lot. You would expect that a cloud with less vertical development, lighter rain, lighter winds, just generally more moderate conditions. This is another cumulonimbus, slightly more vertical development. The more vertical development you get in your cloud, the more likely you are to get heavier rain, lightning, and you're more likely to get microbursts. You're more likely to get stronger straight line wind speeds. So just it can be very difficult when you're close to the clouds as you're sort of sailing through to get an understanding of the vertical height. But if you do get a chance to sort of see the vertical development in your clouds, then that's just a good indication as far as the intensity of any squalls that you're likely to see. Okay, and this one is just, we call it a mackerel sky. This is cirrocumulus cloud. So this is cumulus development in the upper atmosphere. And what this is telling you is you are sailing into an area where you're going to get squalls. That's how you get upper atmosphere clouds, because there is water has gotten into the upper atmosphere courtesy of cumulonimbus cloud somewhere, or a cumulus cloud somewhere. And when you start to see, we started to see this about halfway across. We started to see a mackerel sky, and sure enough, that's when, for us, the squalls really started to sort of come into our crossing. Okay, so we talked a little about clouds. Now we're going to look at squalls, thunderstorms, and wind gusts. And this is a picture of a cloud that caught up to us. I think this is in Greece. Got a nice shelf cloud. A lot of wind associated with this one. But okay, so types of thunderstorms. This is the most, you're most likely to just get squalls like this, a single cell thunderstorm. It's small, brief, usually weak, grows and dies within an hour or so. You're going to see a lot of these. You might get really lucky and not see a single squall, but I don't think I've met a sailor yet who's done an Atlantic crossing who hasn't seen a single squall. So I don't know. You guys, fingers crossed. So single cell storms may produce some or all of the following, and this is in terms of where you are in relation to this cloud. You changes in straight line wind speeds, brief heavy rain, lightning. Um, these are typically driven by local heating effects. So what that means is you're not going to see these in your model output. You're not even going to see these if you're looking at a satellite layer for clouds, because they're small, maybe 1 kilometer. Maybe 1 kilometer clouds that, as I said, grow and die within an hour. So you don't really have any outside um, forecasting ability as far as to identify these systems. You will be able to see them on your onboard radar. The good news about these single cell systems is they usually have a fairly small, plus or minus 10, maybe 15 impact on your straight line wind speeds. I have spoken to people who I've routed across who have had experiences with single cells where they have had bigger increases in wind speed than 10 knots. So I guess the take home message of that is you should, well, my take home message is don't sort of underestimate it just because you see a squall sit by itself. There is still an opportunity, microbursts, water spouts. You shouldn't just assume that you're going to see plus or minus 10 knots. It's a general rule, but as I said, there are certain exceptions. And when you're on an Atlantic crossing and you're seeing a lot of squalls, you will see exceptions often. More severe than a single cell is a multi-cell thunderstorm. So this basically propagates itself at the leading edge. It produces enough updrafts and downdrafts that it basically produces another cell. So whilst individual cells will only last for 30 minutes to an hour, the whole system will last for many, many hours because it will just continue to propagate and it will sort of move along, as I said, often in a line, sometimes in a ball, a blob. And the conditions will be more intense. But these things are typically driven by more synoptic effects. So you are more likely to see these in your weather forecast or your model output or your satellite data. If you are looking at your satellite layer in something like Windy, you will sort of see these as blobs. So you will have some warning that they're coming. Just reiterating here, you are more likely in a multi-cell storm to get really strong straight line winds, downdrafts, microbursts, things like that, heavy rain, lightning, sometimes also even hail. Unlikely in the Atlantic, but yeah. So, but again, these are you're not likely to see these. And as I said, you usually will get sort of, advice from this or input if you're going to get a system like this, and you will get that in your weather forecast if you know what to look out for. So this is important, and I've actually noticed that I should have updated the my headline here because I'm talking about wind gusts. So the winds you experience in a squall shouldn't be called wind gusts. I call them wind gusts, but you shouldn't because by definition, they are actually not wind gusts. A wind gust is something that, lasts for maybe 10, 15 seconds. But what you get in a squall is it's usually like maybe 10 minutes, depending on where you are, 10 minutes, 20 minutes of an accelerated straight line wind speed, which will then return to normal as you sort of come out of that system. But the important thing here is that most weather models are not going to accurately account for wind speeds from within a squall. They obviously have a gust forecast, and the gust forecasts in recent, updates, they're trying to sort of accommodate and account for what you potentially will see in a convective system. But you should not rely on a wind gust forecast to tell you the expected straight line wind speeds from a squall. You shouldn't really rely on any sort of forecast for that. You should sort of look at that system, and you should be, sort of making that determination as far as what those wind speeds are likely to be. And that is something I certainly see a lot. Is people sort of tell me, oh, the wind gust forecast was 15 knots, and we had a squall, and we had like 38 knots of wind, and it's like, And they're like, the forecast is wrong. I'm like, well, no, that's just, I mean, yes, the forecast is wrong in essence, but I mean, the forecast is not designed for that. So it's just a misunderstanding with the data that is available in a weather forecast. Okay, so I'm focusing a lot on squalls because you've got a straight line wind, and squalls are going to be one of the things that's sort of going to mess with your sail plan quite a bit. So it can be difficult to predict what winds you're going to get from a squall. As I said, you're not going to have a lot of clues. You can't necessarily rely on your weather forecast to give you this information. So, you've got to rely on something else, right? And so what can you rely on? Well, previous squalls are a really good example. If you're getting the atmospheric conditions for where you're sailing aren't going to change that rapidly. So if you're experiencing, like 1 or 2 squalls a day, and you're getting like plus or minus 10 knots of wind from those squalls, then you can expect that the squalls that you're going to get moving forward are going to be approximately the same strength. Obviously, if you had a squall a week ago and then you're coming into another squall, you probably can't rely on that squall to give you an indication. But if you've sort of got, like, if you're sort of moving through a period where you're getting quite a few squalls, then that's a pretty good indication as far as the conditions you're going to get from a squall. The cloud base of the clouds associated with the weather system, if the cloud base is quite low, you can expect that you're probably going to get a more severe system. Likewise, if the top of the cloud is very high, you can expect a more severe system. It can be very difficult to ascertain the height of the cloud, though, once you're sort of dodging squalls in the middle of the Atlantic. But the cloud base is a good idea, or is a good indicator, sorry. Sea surface temperatures. The warmer the sea surface temperature, if you are having a positive sea surface temperature anomaly, if any of you guys have been sailing, in recent years in the Med, I'm sure you've experienced this. High sea surface temperatures, are a risk factor for, more intense squalls. You will find, obviously, the sea surface temperatures increase as you head south. The sea surface temperatures will also increase marginally as you head from east to west. So you will find that as you progress into your crossing, you will see more squalls. So another thing, Sahara dust. Sahara dust is actually in the opposite, in that it is likely to suppress squalls, suppress the convection within a squall, and potentially mean that you won't have squalls altogether. So if you do get a Sahara dust plume as you're making a crossing, then that will actually have like a moderating effect on the intensity of any squalls you're likely to get. You will always get access to a Cape forecast. So if your Cape forecast is really high, as we mentioned previously, the higher your Cape forecast, the more intense any storm that you are likely to get is going to be. So that's a good guide. If your Cape is off the charts, then, and you have squalls about, then you should sort of be on high alert for any like strong straight line winds, microbursts, things like that. I don't actually know why I put radar on here. Obviously, you can use your radar to find out where the squalls are. It's not really going to help you predict the winds from a squall. I guess if it's a really big blob, the bigger the cloud, or if it's a collection of clouds, you can expect more winds. But possibly I shouldn't have put that one on there. And again, weather forecast and satellite data. If a system, a thunderstorm is significant enough that it's going to appear on your weather forecast or on your satellite data, then it's a sufficiently large system that you should probably be thinking that you're going to get some pretty significant straight line winds from that. Okay, and just going to reiterate this point again: squalls over the ocean are more common at night. I can go into the details of it if you want. Probably not relevant, but you will see more squalls at night. So depending on, for us, what that meant was we aimed to, before it got dark, we had the boat set up for the worst conditions we thought we were going to get. Our aim was to avoid anyone having to go forward or leave the cockpit in the dark. So that was our strategy. And just something to bear in mind, that you will see more squalls at night. So there you go. Okay, hurricanes and hurricane season. Hurricane season runs from mid-May through mid-November. So by the time you guys are all crossing, most likely hurricanes are not going to be an issue. I just want to touch on it because they're really bad if you do encounter a system. They're obviously very well forecast, but the point is that by the time November comes around, even mid-October, everyone's like, it's the end of hurricane season. Yes, we can start doing things and getting going. And hurricane season tends to start in May, but it tends to ramp up very slowly. It peaks around about now, mid-September, and it does tend to linger. So there will be cases, and there has been cases where, if people leave in November, there will be still some tropical activity going on. And I'm not saying this to sort of like scare you all or anything like that. This is just giving you an example of all the places where hurricanes have started and their tracks. They've started in the week of the 11th to the 20th of September, which is about like the peak of hurricane season. And then this is like more like when you guys will be starting to think about crossing, which is November 21st to 30th. And you can see a lot fewer systems. But the point I'm just trying to make is there are still systems out there. And whilst you might not necessarily get one on your track, if there was one to develop, you could get some significant swell from it. And you do tend to get like very large cloud bands coming off it that it can produce some really significant thunderstorm activity and so forth. So the take-home point from all of this about hurricanes and tropical storms is you're sailing in the tropics. Once you get below the Canary Islands, you're in the subtropics, but about halfway between the Canary Islands and Cape Verde, you're well and truly in the tropics. Once you're in that tropical region, you're in tropical weather. So things like you just need to be aware, no matter what time of year it is, and especially as you're right at the end of hurricane season or as you're getting towards the beginning of hurricane season. Hopefully, when you guys are enjoying the Caribbean, you should always just be keeping an eye on what's going on with tropical systems, because yeah, they can cause a lot of havoc. Okay, so just moving on now to the trade winds, what you're going to use to get yourselves across to the Caribbean or South America. This is them here. So the trade winds are part of a global circulation. Basically, they move air. Sorry, they're part of a global circulation that aims to move heat from the equator to the poles at the cold end. I'm not going to go through all the cells and how that works because it's not really important for you guys. But the important things are the trade winds in the northern hemisphere are a northeasterly wind. The southern hemisphere, they're southeasterly. But these are some of the most consistent, reliable winds on the planet, which is great news for sailors wanting to get from the Canary Islands to the Caribbean. This is another representation of the trade winds. This is the Azores High, which is a semi-permanent feature. In this particular image, sitting right over the Azores, which I like. If you're from America, you call it the Bermuda High. It's sort of, the high does sort of tend to, vary between, where it sits. Sometimes it does sit closer to Bermuda, but usually this is sort of a traditional pattern for it. So it is semi-permanent. And whilst, there can be weather systems that move across that sort of, do like mess with a high for a couple of days, it will usually sort of find its way back to this kind of position eventually. But what it will do is in the summer, in the Northern Hemisphere summer, the Azores High is going to move up. And this is about as northerly as it will sit. It will sometimes sit a little bit above the Azores. In the Northern Hemisphere winter, this is going to make its way down south. It usually doesn't make its way all the way down to the Canaries, but it does tend to sort of sit at the latitude of Bermuda. So it'll sort of sit down here, as you sort of get into winter, and that's probably like a February position, perhaps a bit lower. So you can see to the north of the Azores High, that's all the weather that we don't like. Lots of troughs, lots of low pressure systems, storms, just generally unsettled weather to the north, and the weather to the south of the Azores High, which is what we want, which is nice, smooth, reliable, consistent trade winds. This is just another layer of the trade wind circulation. I think I took it on the same day, but I'm just trying to show you here that what you want to aim for, and it's a pretty big aim because obviously the trade winds sort of cover a large chunk of the planet. But what you want to aim for is you want to get sufficient winds to the south of the Azores High, whilst avoiding as much as you can this area here, which I call the intertropical convergence zone. You may have heard it called the doldrums. Basically, it's the area where the trade winds sort of break down. And you tend to get lower winds, less consistent winds, and you can see here you do get like a lot of thunderstorm activity. So you want to avoid, and as the Azores High moves south, the intertropical convergence zone also moves south. So your typical winter pattern when you guys are getting ready to cross, this whole setup will have shifted, like maybe 10, 15 degrees south, depending on what time you want to go. So you'll have a really nice pattern between the Canary Islands, Cape Verde, across to the Caribbean, and even a little bit further south, sort of down through into South America as well. Because you can see here, if you were doing a Cape Verde to South America at the moment, you are cutting it quite close to the ITCZ, but in a few months, this should be shifted. So that will be a nice clear passage. Okay, so this is just reiterating some of the things I've talked about the trade winds in bullet point form. So a traditional trade wind crossing is below 14 north, so it's just south of Cape Verde. Obviously we have better weather resources now, so we can, better access to forecasts now. So, we can sort of like take a little bit of a broader approach to, where that crossing is going to take place. Sorry about that. So trade winds are the strongest and most stable from December through February. Now, I'm going to provide a caveat there that there's still a massive amount of variability in the trade winds at that time. But, in terms of like the overall stability, December to February, is generally sort of considered a sweet spot. There is also something known as the Christmas trade winds, which, depending on who you talk to as far as, what happens at this point in time, but, it's got something to do with like after the winter solstice. So, obviously that's like the most southern point of the sun. But anyway, so there is this period of Christmas trade winds. It's a period where the trade winds do, for 2 or 3 weeks, increase speeds, and they can blow consistently for around 25 knots. Now, as I said, it's not always reliable. It doesn't always happen at the same time. But, generally speaking, if you were to pick like a sweet spot for when you would want to do your crossing, like that late December, January is usually sort of the time that most people have, sort of would aim for. Obviously, earlier crossings are perfectly fine. And a lot of that is predicated on depending on where you're going and what your plan is. And if you're heading back the other way at the end of the season, you really want to just maximize your time in the Caribbean. So that's why I think a lot of people do end up going in November, which is obviously still fine because, as I said, the trade winds are pretty consistent. They're really always there. So okay, what else have I got here? Oh, year-to-year variations in trade wind strength. This is if you want to get like really nerdy. I don't know what your guys' appetite for this kind of thing is, but I'm sure if you're anything like me, the Atlantic crossing is probably like occupying a lot of your time at the moment. So what are the trade winds going to be like for you guys? So there is something called the North Atlantic Oscillation. We call it a teleconnection, and it's basically some weather patterns, which if it's in a positive phase, it means you're going to get stronger trade winds. If it's in a negative phase, you're going to get slightly weaker trade winds. Now, I'm sure you guys want to know, okay, what's it at the moment? And I had a look, and it's not really very exciting. Sorry. It's fairly neutral at the moment. So what that means is it's not going to be too strong. It's not going to be too weak. You're going to get like a Goldilocks crossing. It's going to be perfect. I don't know, but anyway, we can hope. So the North Atlantic Oscillation, there's a website there if you guys are particularly keen and you want to check that out as you're getting closer to your crossing. It usually doesn't vary that much. I think you have to get up to like, a 4 or a -4 before, you're really going to start to see something. So I don't think it's going to be much of an impact for you guys, but something to consider. Okay. I'm not sure how we're going timings wise. I'm not sure if I've still got you all with me, but thanks for bearing with me if you're still here. This is just getting to the trip planning stage. I've sort of covered some aspects of the weather, and now I guess we'll just sort of tie it together as far as what you guys can expect on certain parts of the journey. Okay, So the first part, getting to the Canaries. My first bit of advice is don't wait too late to make your run. Um, whilst you're north of the Canaries, it's temperate weather conditions, so very, very seasonal. And as you saw from the position of the Azores High, as it starts to shift, your um, mid-latitude storms, low pressure systems, they're going to start tracking further south. So, they're going to start messing with like Biscay, and it's going to start to get really cold as well. So basically, the later you wait, the good weather windows are just going to become more rare. And you'll find yourself sitting in port for longer, waiting for weather windows. So yeah, that's just my bit of advice. Don't wait too late to make your run to the Canary Islands. I actually had a discussion with Peter about this because Peter's I've done one Atlantic crossing. Peter's done many, many more. And Peter's feedback on this or comment on this was he's once you're sort of where Gibraltar is, you're pretty much reasonably insulated from any sort of conditions that are sort of particularly too bad. But if some of you guys are sort of coming from the UK still or the Baltic, yeah, don't wait too late to make your run. I'd certainly want to be sort of across Biscay as soon as earlier rather than later. It's going to be colder as well, like colder air and sea surface temperatures. So it's going to be less fun. Obviously, it's going to start getting not too bad at this time of year, but it's going to start getting fewer sunlight hours. Another thing I'm going to make a point of is just, if you can, and if there is sort of some decent swell from some storms coming in the North Atlantic, just try and stay off the continental shelf if you can. Obviously, if you're hopping down, I think someone mentioned, it's fairly imperative to stay close to the coast when you're near where the orcas are. But if you are sort of heading out to the Canaries and you're sort of in the open sea, there is a tendency to sort of hug the coast. But if you do have some big swells, as soon as you do hit that continental shelf, even though it's still quite deep, you will sort of still see like a bit of an uptick in the swell. So if you want to sort of increase your comfort, aim to stay off the continental shelf. We did also 90 miles offshore of Morocco. We did nearly run into a fisherman who didn't have AIS. He was a very long way out in a very small boat. So, but that's not really weather related. So I won't talk about that. And depending on your port of arrival, as we talked about the local effects, just be cognizant of your weather models and the weather forecasting tools that you are using as you approach the islands, acceleration zones, things like that. Just be prepared for those effects depending on your port of arrival. And, Gran Canaria, mainly south of that, but that's certainly is an area where there is, quite a significant acceleration zone. Okay, so once you've made it to the Canaries, the next step for a lot of you is going to be down to Cape Verde. This is usually about 5 to 7 days. So, well within like a forecast window, which is pretty nice. Again, I'm just saying, watch out for the local effects, the acceleration zones. As I said, don't rely on the weather forecast and the weather models with respect to those acceleration zones and local effects. I just check the status of tropical storm development. I'm gonna say that a lot, just because it's just important. It should sailing in the tropics. It should just be something that you're thinking about constantly. But if you do want to leave early, it's also quite important because the official season ends November 15. I can't remember the date of the arc, but I do think that the arc leaves for Cape Verde. I think it's the 3rd of November. Not 100% sure, but so people do leave and start heading into the tropics during the hurricane season. So it is just important to know what's going on there. Okay, so you're going to get subtropical weather patterns for about half of this journey, and then like halfway through you hit 23.5 degrees, and I think then you're in the tropics. So it's pretty. Once you're south of the Canary Islands, you're not going to get lows. You're not going to get any storm activity, anything like that. You might still get impacts from the swell from North Atlantic storms, but not the storms themselves. You'll be well and truly into like a trade wind pattern at this time of year. It's really the thing you're going to be most focused on is, how strong is the how strong are the trade winds going to be in your particular departure window. So again, squall likelihood is going to increase as you move south because it's just going to be warmer. And obviously we talked about the fact that your weather forecast for that particular passage, you should have quite a high degree of confidence in it because yeah, a 5 to 7 day window is yeah, it's definitely easy to forecast. And in the open ocean, you're going to have a lot of faith in that forecast. Okay, so now we're looking at Cape Verde to the Caribbean. All right. I like this part. Well, not that we did this part, but once you sort of get to a certain level south, you don't have to wear the beanies and the jackets, and it's nice warm weather sailing in the trade winds. It's very good. Okay, so you're looking at about 12 to 15 days. Again, either side of that, depending on the conditions, depending on the speed of your boat. So you're not going to have a reliable weather forecast for your entire journey. You want to consider having a look at the tropical hazards outlook, because that data is just always very useful as far as what you can expect, mainly in terms of squall activity. But squalls are pretty important for your journey. Again, check the status of tropical storm development, always very important. And on this passage, you're going to be quite far south. So you might get some swell, but you don't really need to be sort of too worried about what's going on in the North Atlantic at this point in time. But always you're going to have a lot of time on your hands, so it's always good to just be cognizant of the weather influences and their potential impact on you, wherever they're coming from. So this one here, this was interesting because this is based on some feedback of some people who crossed in the years before us and who when we crossed. So the trade winds are traditionally, they're northeasterly. Obviously, they kind of like curve so that when you hit the Caribbean islands, they're pretty much like an easterly wind, but they can still have a little bit of north in them. So when you're leaving Cape Verde, this is depending on where you want to head to. If you want to head somewhere north of Barbados, there, you will be taking some of that swell on the beam, and depending on the sail configuration, if you're sort of trying to run with like a downwind configuration, on a monohull in particular, you can get quite a bit of roll. We had some people who, when we did the passage, and they did, because we did more of a run line, and they did from Cape Verde, they said they had a lot of roll and quite a significant amount, and they said it was fairly uncomfortable. So something to think about, as I said, especially if I don't know where your destination is. If you wanted to sort of like head to Antigua or something, fairly unlikely, but just something to consider, that you will be sort of taking more swell on the beam. And again, here, just you will expect squall frequency to increase as you move west. Just the sea surface temperatures just generally increase in that direction. I can't think of anything else to say about this passage at this point in time. So I'll move on to, so this is Canary Islands, straight to the Caribbean. I wasn't going to put an image up of the islands because I've already done that. So I put an image up. This was our first night at sea. We just come out of the acceleration zone between Gran Canaria. Pretty calm. But anyway, so this is what we did. Now, we did a run line route, but I'll go through the list. So this is a longer passage, 2,700 nautical miles, approximately 16 to 28 days at sea. I had one group that I routed that were 28 days. I felt, yeah, it was a tough passage for them. They had very little wind. But anyway, traditionally what you do, head south till the butter melts. So you head south until 14 north and then turn west. So you kind of head close to Cape Verde, and then you sort of scooch across. The other route is the Rumline route. It is shorter, and this is the image that I showed you first. This is what we took. It does have the potential for a more downwind run, bearing in mind you've got a northeasterly trade wind. That you're taking the swell more on the back of the boat as opposed to the beam. And basically, our approach when we did it was we pointed our boat at Barbados, and we sort of went for it and adjusted as we went. I will say that you are under the influence of subtropical weather and swells for longer. So what this means is, if you remember the image of the Azores High, sometimes that system is disrupted. The further south you go, the less likely you are to be influenced by a disruption. If you aim for a run-line route, you are more likely, if you're not paying attention to the weather, that you could be in a situation where, there'll be some disruptions at the Azov High. The trade winds to the north will sort of, collapse a little bit. So, you might have like a great run for like 6 days, and then you find yourself in an area where you've got no wind. So you have to be cognizant of influences from the north. When we did this route, we adjusted our. I mean, when we set off, it was fine, but our sail plan when we left Gran Canaria was, we'll see what the weather's going to do, and we ended up having a great forecast, so it enabled us to just point. But if you are going to do that, then you just need to be aware that you've got a sufficiently long run of your weather forecast so that you've got good weather, or you've got good conditions before you sort of hit that 14 north, where the winds are sort of pretty much, they're just going to be there all the time no matter what. Again, squalls, whether you're doing a traditional route, whether you're doing a run-line route, you're going to get more squalls in the second half of the trip. Again, you want to check the status of tropical storm development, because you want to do that all the time. And that tropical hazards outlook data is just really useful as far as, if you want a bit of a long range idea of making some plans and just knowing what's coming. We're very nearly towards the end, so I'm just going to cover really quickly trip planning if you are planning on finishing in South America. And I've included a picture of the currents here. It sort of might give you a bit of an indication of one of the important things to consider if you are doing this passage. So let's just cover it here. If you are ending up in South America, it does allow you a nice, a more downwind run from Cape Verde. And I think it's the shortest distance. I think Cape Verde to French Guiana is like 1,100 nautical miles. So, you can do that like 10, 11 days. I think it's probably the shortest passage. I said I didn't verify those numbers, so don't hold me to them. I'm going to say, yeah, you want to check for tropical storm development, but like even in the middle of hurricane season, it's very rare that you get storms along that route, because you're very far south at this point. The thing you do have to be more careful with if you're going to be doing Cape Verde to South America is you need to be cognizant of where the intertropical convergence zone is, and whether you're going to get too close to that, and whether you're going to have really increased squall activity as a consequence of that. The tropical hazards outlook, again, will be really useful for that passage. Because you are further south, everything's just warmer, there's just more energy, you are more likely to expect more intense squalls. And the last point here I just want to make is you really want to watch out for currents as you approach South America. And I'm just going to highlight that here. Because you've got your winds and your waves coming from a northeasterly direction, and then you have a very, very strong current coming up the South America, and which usually just flows straight up, but you do always have these eddies that come out, and these eddies, this white area here, it's up to like 3 knots of current, and if you've got a pretty strong trade wind behind you, which is kicking up some nice big seas, and then you hit a 3-knot countercurrent, obviously it's going to slow your progress, but it's also going to significantly steepen those waves. So you'll get this situation where you've got like waves against current. And I'm sure you guys have probably experienced, like waves against tide and current in, certain areas. But it's definitely something that you want to be wary of if you're sort of making this approach, that you sort of avoid the positions of these eddies. Especially as you approach the continental shelf, because you can imagine you've got like a counter current, you've got the waves behind you, you've got the continental shelf, which is going to like steepen the waves. So you just really want to be careful that you're not going to just put yourself in an uncomfortable position with the waves as you approach the coast there. Now, I've got this little image on the side here. This is from LuckGrib, which is one of the apps I talked about previously. LuckGrib gives you access to a current forecast, which is called RTOFS. Now, RTOFS, I can't remember what the acronym means. PredictWind uses RTOFS to do routing. So if you are using PredictWind, it should help you to avoid these eddies and countercurrents. But I do find that in PredictWind, it is very difficult to get the actual forecast, to see the actual forecast yourself of where these eddies and where the currents are on the South American coast. So if you are planning on going to South America, my suggestion would be you would like to sort of get some visibility onto like the RTOFS, I think is the best model output that you can get for looking at where ocean currents are. I would be looking at RTOFS and seeing if I could make sure that I could view the data myself, just to give myself extra certainty. If you have the data, you can usually get a current forecast about 6 days. I think 4 to 6 days is about the timing you'll get a current forecast, and you can usually just make sure that you can avoid any eddies and just make sure that your arrival is as comfortable as possible. I think that's it. So happy sailing. How did I do, Peter?
I did. I think you did very well, Julie. Lots of information out there. We have quite a bit of questions coming in on the chat channel. So if any questions come to people's mind, please add it to the chat channel. We go into the Q&A. We had some questions which were coming in through the group already before the webinar, Julie, so I'm shooting them off one by one. Some of them were answered already before or partially answered before, but I think it's good that we go over them again. One of the questions was, is it safe to leave early from the Canaries to Cabo Verde? Or say Senegal area in Western Africa, as early as late September and or October?
So my answer to that was yes, I genuinely think it is. Obviously you're still in hurricane season. There are some really good resources about the climatology of hurricane season. And what happens is at the moment, so like, yeah, obviously right now we're in September, but after this month, the main development region for hurricanes moves further west. So right now, they call them Cape Verde storms. Their origins are around Cape Verde, but that will move in the coming weeks and coming months. That will move further west. And there's some really good data. I showed you some snapshots of like tropical storm development in September and then in November. There's like week on week images of those, so you can see how storms change. And if you're just going out for like, what Canaries to Cape Verde is, say 7 days. So you're going to have a forecast for that. With the tropical hazards outlook, you're looking at where the MJO is. Yeah, look, the weather forecasts, the data is there. As long as you're not going out, without checking the weather, then I think that you can go early. I mean, yeah, that would be my advice. But, just be very cognizant of and make sure you're familiar with all the resources that you have to check the weather. So.
Yeah, and if people think that the hurricanes only happen over the Caribbean and the southwestern part of the States, just a reminder that it doesn't have to be a hurricane, it can be a tropical storm also. I think when Erin was born early on and came over Cabo Verde, this is a couple of weeks ago, we probably saw in the news the heavy rain that it brought for, I think it was for several days, and actually caused quite a bit of flooding in Cabo Verde. Of course, this was still August, and as you say, they move further west. So probably late September would be safer, at least not to cross the transatlantic, but at least go further south towards Cabo Verde, no?
Yeah,
Yep.
100%
I
agree
see. I
with.
see you nodding.
Sorry, yes. No, you're absolutely right, Peter. Yeah, I think that's spot on advice.
Okay. Another question that came in, and this was, I think, already quite covered. I'm just reading out the question, and then you see what you want to re-emphasize, Julia. The question was, can you please give some tips on using visual and onboard clues without relying on the digital forecast? Red sky at night, sailor's delight stuff. But also more what the various clouds indicate, what the pressure changes mean. And I think that's maybe something that you could elaborate a little bit on. People sometimes, when last year with Finding Dory, people were kind of half panicking because they saw a pressure of 1009 in the predictions. They said, "Oh my God, there is a low pressure coming. We're going to have a storm leaving Cabo Verde." Um, so, what does the pressure changes mean going transatlantic? Let's say doing the actual crossing. Um, and even just pointing at some of the good resources that would be sufficient to use for visual aids and other aids. You mentioned seawater temperature changes, for instance. Something I want to re-emphasize on this, Julia?
Well, I'll just reiterate, yeah, the sea surface temperatures, the clouds, the mackerel sky, I've always found is a pretty good one. The red sky at night, red sky in the morning, I've never found that that's worked for me. I'm trying, like red sky at night is good, red sky in the morning. But yeah, so sorry, I can't comment on that one. With respect to pressure changes, though, I mean that is actually a very good one, and I simply forgot to touch on it. I use so I look at pressure changes over time. So I'm less interested in the actual pressure itself, but I'm more interested in how it changes over time. I mean, really, on an Atlantic crossing, especially if you're sort of doing like a 14 north, so you're straight across, you really shouldn't expect some major pressure changes. If you do start to see pressure changes, specifically pressure drops, um, then yeah, you I mean, if I started seeing pressure drop, the first thing I would be doing is I would be looking at a weather forecast or a satellite view to see what was happening. But yes, it's so for me, I'm not necessarily concerned with, okay, if it's 1009, it's less likely to be an issue than like 1015. That's less what I would be concerned about. But if you are interested in tracking the pressure, you just want to be seeing, is it consistent? And
Mhm.
you should see it consistent. If it does start varying, specifically if it does start dropping, then that is definitely requires further investigation, I would say. Yeah. So, and you talked about onboard resources. I'm sure you guys do it. The
Yeah.
weather radar. Oh, so your radar. It's not actually a weather radar, is it? It's just a radar. But yeah, like it was so super useful for us. We did find that in some cases, because we were sort of, with it, we had flexibility in our downwind configuration that, we could see storms a long way out, and we had the ability to sort of make small shifts to just sort of avoid issues. So there are certain resources, and you're right, because when you're offshore, it is very much like, yeah, sort of more visual cues about what you're seeing. So I hope I've answered the question a little bit with respect to visual cues, but yeah, feel free to sort of ask more if I didn't cover anything that you needed.
Yeah, and you mentioned the sudden changes in pressure, which are probably more significant than whether over days and days you have you read a low pressure. But I think that's also true for temperatures. If all of a sudden you see a raise as you cross the Atlantic, and all of a sudden you see that the ocean surface water temperature is raising for 1, 2, or 3 degrees in 24 hours, that is also significant, no?
No, yeah, that's absolutely right. Yes, that's a good point. Yeah, if you sea surface temperature, I mean air temperatures as well to a certain degree, because if you do see a sharp shift in
Yeah.
an air temperature, it means you've moved into a different air mass. But no, sea surface temperatures definitely are an important one to keep a tab on, because a significant change in a short amount of time, it does sort of mean, and like that's where the energy for the tropical weather that you will experience is coming from. So yeah, that is a very good point, Peter. That's something to be aware of. So yeah, your onboard sea surface temperature thermometer is something which, yeah, you should be checking several times a day.
Yeah. Okay. I have one question that I noted for myself. You mentioned significant Cape figures. So, as of what figures for Cape should we be worried about? Is the Cape of 1,000 something to be worrisome about, or is it 2,000, 3,000? Of course, you will answer probably the higher, the more likelihood of higher energy. So clouds forming much quicker and then probably developing much faster into saturated cloud and a rain cloud, potentially a squall. But when I go across and I see a cape of 1,000, should I be worried?
So 1,000 is usually like the threshold that we sort of say to people. Like if it's below 1,000, some people say 800, but if it's below 1,000, you're probably unlikely to see a squall, especially on the ocean, right? Because there's no land, there's nothing that's pushing, causing convection to happen. So there's not really there's not really anything perturbing anything, so it's pretty settled. But as soon as you get above 1,000 joules per, I can't remember what, but as soon as you get a cape above 1,000, then then the conditions mean that you have energy in the atmosphere that if there is sort of a perturbation at the surface, then it's probably going to shoot up and do something. Obviously, and as you mentioned, like the higher the cape, it means it's just there's more energy, so it means that things are more likely to develop. But 1,000 is a good level. If you're at 1,000, it's like, yeah, you're probably going to see but if you see a squall and it's at 1,000, it's probably going to be fairly minor. One of the things, and this is sort of less on like an open ocean crossing, but sometimes you'll see a forecast, and you see it in the Med a lot, especially when you have the high sea surface temperatures. You see capes of like 4,000, and it is very high. And it's just something. What you need to be aware of is you can actually sail through an area of a cape with 4,000. And if there's nothing that's perturbing the atmosphere, then it's not a guarantee of a thunderstorm, but it does mean that they are more likely, and it does mean that if you are going to get one, it is going to be more intense. But it's that 1,000 is usually the threshold that we sort of say if it's below 1,000, it's pretty unlikely that you're going to get a squall. Yeah, is that?
Yeah. Indeed, indeed. I had a discussion with Chris Tips, the meteorologist working with the Arcobot, is what would be the good indicators for the squalls, and he said, well, the cape is definitely a good indicator. But it doesn't mean that you have a cape of 2,000 or 3,000 that you are guaranteed to have violent squalls during the night. But also look at the predictions of precipitation of rain. Normally, it's the combination of a high cape with predictions of rain that show an increased likelihood of let's say significant squalls.
Yeah. Oh, definitely. Yeah. Yeah, for sure. Yes. Yeah, that's true. And I mean, usually, yeah. And usually the ones, as I said, the ones that go under the radar that, you're not seeing in a rainfall forecast, they're usually fairly mild. I mean, maybe I would sort of say yeah, I mean, that's it's pretty fair. I mean, because the other thing is there are things other than Cape as well that are, I mean, as meteorologists and weather researchers, we look at something called convective inhibition, and it's like the opposite of Cape. So you can actually have a very high Cape, but then you can also have like a cap on the atmosphere, which is resisting Cape. So there are other factors. But as a general rule of thumb, sort of looking at those Cape values, and it's just as I said, it's just usually it's just something to be aware of. If you're sailing under a Cape of 3,000, I mean, from my perspective, that means I would probably be, like well reefed at night, because I'd just be if something were to develop, it's probably going to have a bit of energy in it. That's sort of my thoughts on it. But as I said, I
Yep.
prefaced all my advice with I'm a very conservative sailor. So
Yeah, exactly. And so should we, if we want to cross, not in a regatta, but safely with family and keeping our boat in one piece, for sure. Um, the We touched on acceleration zones. There was a question from Julie. Are the acceleration zones around the Canary Islands always south of the islands, or can they be north as well?
very unlikely to be north, simply because of the prevailing winds. Basically, what happens
Correct.
is the islands they'll act as a wind shadow, or they'll channel it. So if you can imagine, Gran Canaria is just like a big round volcano. So, when the wind hits the volcano, it's going to not be windy behind it, but it's just going to, all that wind, all that energy from the wind is just going to funnel around it. And that's why you get the acceleration zones. When we were in Canaries for 3 months, we did have a period of southerly winds. And in that case, we had a anomalous low that came down, and it was very short lived. In that case, you probably would, but I mean, there's no one was out sailing in that anyway. So yes, you can, but very unlikely. Traditionally, that's the acceleration zone through, because that's just the prevailing winds. And I think I can't remember the exact figure, but it's a fairly consistent wind. Like in the Canaries, it's like 80% of the time you're going to get that northeasterly sort of. Yeah.
Yeah, yeah, exactly. To summarize, well, it depends where the prevailing wind is coming from, and with the Canaries, as you say, mostly it's a northerly, northeasterly. It's the same in Cabo Verde. It's mostly a northeasterly. So you would have funneling between the islands, and then the acceleration would happen in that funneling trough between the islands, and then more towards the south and the southern edge of the islands. And then you have then the opposite. You have also the wind shadows, of course, from the mountains, from the volcanoes, which actually can be quite drastic. It can be that you just sail 1 mile further east, or 1 mile further west, and the wind changes from 15 knots to 40 knots or 40 plus knots. It's almost like you're passing a gate, and all of a sudden there's nothing, and you can actually see it. We were talking about visual clues on the previous question. Looking at the surface of the sea, the can tell you a lot of what is coming. Also, when squalls are coming. Um, and again, to emphasize, it's not only the Canary Islands, but also the Cabo Verde, especially for those that go towards Mindelo. Mindelo, I think the highest point is somewhere around 900 meters, and then the island right next to it is 1,900 meters, and that produces a very significant acceleration zone and wind shadow. But then, as we go typically from Cabo Verde, we go southeast. We have to make sure that we go southwest. We have to make sure that we keep out of the wind shadow of the Pogo volcano, which is 3,000 meters high. Although it is quite far away, that wind shadow stretches for hundreds of miles beyond the volcano. Anyway, that was a little bit of my wisdom. um, Let me see. Multi-hills from Carlin. Any suggestions for multi-hills going directly from the Canaries? You mentioned waves, that probably you have more of a chance that you would have the waves more directly from behind. Any other suggestions going straight from the Canaries to the Caribbean on Rumline on multi-hulls?
Well, I have to confess, I've never sailed on a multi-hull, Cullen. So sorry, I can't give you any sort of specific advice on that. I mean, we found that when we took the Rumline route, we did very much have the waves. We were running with them, and it was quite good. Let's say we were pretty much always taking them, right on the stern. But yeah, I could try to think of something, but I probably would. Peter, do you have any? I know that you have done some crossings on multi-hulls. Do you have any sort of input on that you could add? I'm very much a catamaran novice. Sorry, Callan.
Yeah, yeah. I would think it's probably the same for a multi-hull and for a monohull. Is if you take the rum line from the Canaries straight to the Caribbean, then I would be much more careful in watching weather predictions, and I would be much more conservative in my planning. That's why typically, unless if I race. Um, that's why I don't like to go straight rumline, because according to me, the chances that you're going to have the effects of the North Atlantic lows, either eating up your trade winds or creating a headwind, which is not very comfortable in an ocean passage. That is not a happy situation. So it is perfectly possible, according to me, to go rumline monohull or multi-hull. But I would be much more careful in watching weather predictions. I feel much safer to go down towards Cabo Verde, and then somewhere, my golden area is, as you mentioned, 14 knot, and going down to I think maximum about 11 knot. That's like my golden envelope to cross, because we have less influence from the North Atlantic lows, and we have more stable trade winds, and this also means more stable waves. So I think it can be perfectly good with a multi-hull going rumline from the Canaries to the Caribbean. But unfortunately, I think it can hit unlucky also if there is a big North Atlantic low that influences not only the weather but definitely the waves. And you were very very right to say, going from the Canaries to Cabo Verde, in that latitude area, you are very unlikely to be hit by a direct storm, but you will be hit by the consequence of that storm, which is waves directions, wave period, and eventually the winds, which from a low going counterclockwise, they eat up your northeasterlies, they neutralize them. And you might have several days of no wind, or even worse, headwind.
Yeah, yeah, good advice.
Alrighty. Then from Joe, there was a chart where there were figures for wave height and swell height. What is the difference?
Okay, so it's sort of, so when you look at a forecast, I'll see if I can go back to it. Hang on. Oh, here we go. Bear with me. So when you look, I'm getting there. There's a few slides here. There we go. Okay. So when you have a look
I
at,
I, I
you're
love I
given,
love this slide. I absolutely love this slide.
this was a late edition, so I'm glad it's popular. No, it is actually, it is really useful. I do like this view from Wendy. So when I mean, you can see the background layer. That's giving you like the as I said, it's the most energetic wave. So on that particular dot that I have, you're influenced by three different. So you have the wave, and the wave is usually like it's the wind wave, right? So
Mhm.
in this case, you've got 17 knots of wind. So, that's your wind wave. And I don't know what 17 knots of wind with a limited fetch is going to give you, but, it'll give you like about 2 meters. Um, so you're going to get a 2 meter wave, like right behind you, assuming that you're running dead downwind. I don't know.
Mhm.
I've assumed you're running dead downwind. But then, you're also going to get, and in terms of the period of that wave, if you have a look at the forecast on the different layer, not on this particular layer, it will give you the wave period, and it will give you the period of the most energetic wave, and that in this instance is your wind wave coming down. So you will get the wave direction and the wave period for your most energetic wave, which is your wind wave in this case, but your significant wave height forecast, which is not what you're seeing down here. This is a breakdown. Your significant wave height forecast is going to be the combination of all of you've got your wind wave, you've got your North Atlantic swell influence, and you've got your South Atlantic swell influence. So um, whilst you don't really need to sort of like have a look at this breakdown, I like to look at this breakdown because what it's telling me is it's giving me an indication of, okay, like, what are the seas going to be like? I mean, in an ideal world, you just have a wind wave and it's just one and they're pretty consistent. But, the reality is what you end up getting is you sort of get like this swell comes in and, this swell comes in, and sometimes you can see them. Um, and, but sometimes they'll like cause a wave to peak, or sometimes, it'll cause the waves to sort of flatten out. Um, I guess one of the situations you sort of want to be a little bit careful of is, this North Atlantic swell, because usually it's going to be a North Atlantic swell. It's not usually going to be the South Atlantic. If you've got like a 2 meter wind wave coming from like a 17 knots forecast, or 17 knots of wind, but then, you've got like a 1.5 to 1.7 meter swell coming from the north. So, they're whilst your wind wave is still the more energetic wave, you've still got quite a lot of energy coming from this one too. And you will get quite a confused sea in that circumstance. Another circumstance is, if you are in a situation, and Peter mentioned this when we were talking about the rumline route. if you do get a situation on your rumline route where you have light winds because of a low, but your winds are fairly light, then your wind wave is less energetic. And then if you get the North Atlantic swell pushing down, that is going to be your most energetic wave pattern. And, then like you're very much taking it on the beam, and, that can be quite uncomfortable. So yeah, so that rumline route, as Peter mentioned, we had a very good run on it, but it is definitely, you need to sort of, yeah, at 14 or 11, like between, as I said, Peter, that Goldilocks zone that you mentioned, you can almost, not quite, but you can almost sort of sit back and relax. But on a rumline route, you want to be like, just being, checking out those swell patterns, checking out the wind patterns, and definitely paying attention to like the synoptic situation in the North Atlantic. So yeah. Does that
Yeah,
answer your question about the different swells?
yeah, yeah. Definitely. And something probably good to mention. You mentioned confused seas. One of the phenomena that we see when there is different waves coming together at the point where we are sailing is the phenomenon of standing waves. Is where one wave accumulates on top of the other, where you would have an average wave height, for instance, of 2 meters, and all of a sudden you're hit by a wave of 4 meters because one wave that comes from the other direction climbs on top of the wave coming from the opposite direction, and you're hit by a 4 meter wave. There are
Yeah.
occasions where we do transatlantic, and 4 days it's been nice. It's been 2 meters swell coming from aft. We start opening up the hatches and relaxing, and then all of a sudden, out of nowhere, comes this massive 5 meter wave that floods everything and runs down into the from the cockpit into the galley, all up to the forward bow inside of the boat, and that was a standing wave.
Yeah, yeah. Yes.
I think people might get the impression we're trying to scare them.
No, no, no. But it's definitely like having a look at the different wave patterns is good. And yeah, it is really, it's valuable to sort of know. And in an ideal world, if they're all sort of pointing in one direction, it's really nice. If you do start getting like
Mhm.
different wave patterns and like from a lot of different angles in that circle, yeah, it just is a pretty good indication. You might get some, especially if they're approximately the same energy. It's something to, just something to be wary of. But yeah, as I said, quite rare that
Yeah.
you do get that.
Yeah, indeed. From Julia and Julian on Dalaria, what are the major currents that we can consider? You take it from the Canary Islands, going to Cabo Verde, then going across. So, what would be the major currents that we should consider? And what are the best sources of information to get them? They had another question about Gibraltar, but I'll come to that later. Go ahead, Julia. Julia, you mentioned some of them close to South America as we approach the Caribbean. I think these are the most significant ones. Any other currents that we should consider?
So that is an interesting. It is an interesting question about the Canaries and the currents around there. I don't actually remember. Sorry, I can't. I can't find. Oh, it's right at the end. Yeah, I don't even have a picture of the currents in the Canaries. So, but generally speaking, as you can sort of get a bit of a view from this picture that I've got up here, if you're doing east-west crossing, like everything, the currents are in your favor. You're probably going to get like a half knot assist for most of the journey. And when the current is going with you, obviously a half knot current is not huge, but the current moving with you does give you the advantage of it will flatten a wind wave slightly, just because like the water is moving in the same direction as the wind. So generally, the only currents you do need to be worried about on this passage are, if you're doing South America, and you just need to sort of be cognizant of those eddies, because they could, they're just sort of make things a bit uncomfortable. But you
Yeah,
can see like over here,
and it's
everything is
strong,
just
huh?
is pushing, and it's yeah, they can be very strong. I mean, I must say I chose this particular picture because these eddies are sort of quite significant. They're usually not that bad. And you asked about resources. I really, really like the RTOFS model. As I said, I actually don't have a current predict wind subscription because I'm not doing offshore passages at the moment. Um, but I know in the past that RTOFS, it's been difficult to actually get the view, like this sort of view of the actual currents. Windy doesn't have RTOFS. This is the Euro model that Windy has. But LuckGrid, which is the app that I talked about, and I can always send you guys some more information about LuckGrid. It is a really great little app. I think it costs like $6 or something, but I would recommend it because it has lots of low bandwidth features, obviously not too important these days, but you basically just draw on the UI the area that you want to see. You hit download and then you get your little picture for 6 days of your RTOFS current. And it is, as I said, RTOFS is generally considered I think it's an 8 kilometer resolution, it's very high resolution. It's a really good current model. And as I said, that's what PredictWind uses for their routing, but it's just difficult to see it in their like UI. So that's why I really like LuckGrid to see the RTOFS forecast. So yeah.
Yeah, look, if you can do me a favor, Julia, after the webinar, if you can give the links for resources on currents, I
Yeah.
think this would be useful. Yeah. I use windy.com, the currents in windy.com, but probably they're not as accurate as the ones that you have.
I will say that Windy is very, very good. Like, but this is what I do as, well, I like to say I'm a sailor, but my other job is weather. And yes, and so yeah. But no, Windy is very good. It's not like it's going to steer you wrong. But for example, if you were trying to use a current to get an assist, like if you're trying to pinpoint the exact position of the Gulf Stream to shoot up somewhere and you want that
Yeah.
extra accuracy, then RTOFS is really good for that.
Yeah. And on the a little note from experience on the strength of the currents approaching Grenada and the eddies that you have, there were actually instances could feel it in the boat. Where actually it woke up the skipper on not the last passage, but the passage before that I did, because you could feel the boat being pushed by the eddy. And this is in plain ocean. We couldn't even see land yet. But an eddy was like turning the boat. It was almost going through the Needles in the UK. Very surprising to see this in the middle of the ocean.
Yeah. So were you approaching Grenada at that point? Were you sort of in this
Yeah,
area here?
yeah.
Yeah.
Yeah,
Yeah, that's
yeah. So it
it's
was the
sort of
current that came from South America and bends over Trinidad and then goes towards Grenada. So about
yeah,
I think was pointing almost straight north, northeast. Yeah.
yeah.
All right. Julia and Julian also had a question about currents, sources of current information for instance, the Gibraltar Strait. But I think that's an animal by itself, no?
Yeah, I mean that's because it's very tidal.
Yeah.
I mean it predominantly flows out. I Yeah, so or is it in?
In, in,
Thank you, Peter. Sorry,
in.
I've been looking at it's been a while since I've been in the Med. Yeah, okay, so it predominantly flows in, but it is very. I believe the Predict Wind is pretty. They have a pretty good interface for the tides and what you can do in Jib. And as I said, it's as I just demonstrated, I'm a little bit out of touch with the Med, considering I got the prevailing current direction wrong. But I will say that in an area like Gibraltar, a little bit similarly same in the Straits in Messina. And if you guys do end up getting over and you spend any time in North America, and you're trying to, because obviously the Gulf Stream is significant here. Um, Generally, if you sort of stick to fairly shallow contours, you're going to be okay no matter what you do. And I know that sticking to shallow contours is something that is usually recommended, obviously from an orca standpoint.
Mhm.
That would be one piece of advice I have. I know Predict Wind is good, but I mean, really, Peter, if you have anything to sort of jump in with about the Med currents at that point, feel free because yeah, you probably have more
Yeah.
experience with that at this point.
Yeah, I think it can be planned quite accurately. So you have two things. You have the tides and you have the currents. There's always current flowing in the bed because water evaporates faster then water comes in the mid. So you always have, I think it's a 1.5 knot of current going in, always. But then on top of that, you have the tides, which are, of course, perfectly predicted. And then if you plan your passage through the Gibraltar Strait, you need to keep in mind the wind direction versus the tide. Um, you don't go wind against tide in the Gibraltar Strait. And what makes it also complex is that you can have tides which run differently in the middle of the strait as on the edges. Very early on, I think in May, when we started with finding Dory, I sent over the tidal maps for Gibraltar Straits. I can distribute it again to the group now, but you can plan this pretty accurate. And so you basically combine your tidal information then with the Orca map that we tackled in the last webinar, and that should more or less define your route as well as the timing going through the strait. But the golden rule is never go wind against tide. And again, really talking about funneling, just a few moments ago, there's quite a bit of a funnel in the Gibraltar Strait, wind funnel. Monica from Viver said, where can we get the best information about currents in South American currents? You already covered that. All right. David says, would you recommend the use of a weather routing service? Are there any advantages over forecast service subscriptions? And I think David, correct me if I'm wrong, I think probably he means use of weather routing services, people that guide sailors across the ocean during the ocean passage.
Yeah, look, I mean, honestly, I think it depends on your comfort level. I mean, I haven't done routing for a few years, and when I was routing people across the Atlantic before Starlink, so I would do some routing with people with Garmin inReaches where I could send them 144 characters at a time. Um, but honestly, I mean, it depends on your comfort level. I mean, sometimes people really appreciate having someone to throw ideas back and forth from. Starlink, obviously, you have got like all your fellow crossers, and you've got your flotilla members to do that with. Um, yeah, I mean, I think. Yeah, I don't know. I mean, if it makes you feel more comfortable, but I honestly think that the resources that you have available, if you just sort of spend some time, familiarizing yourself with the resources and getting comfortable, I think that you probably wouldn't need it. Perhaps if you were thinking of doing a crossing in September, and because you absolutely had to, and you were dealing with some complex weather patterns, then in those circumstances, or you just had to meet a schedule, then weather routers are pretty useful. But um, a December crossing, with Starlink, or a November to February crossing, or really any time like that, and that's not in hurricane season. I think that with you could go it alone, yeah, fairly easily.
Yeah. Any experience you had, Julia, with the routing functions in PredictWind? So now in PredictWind, you say I want to go from A to B during this time, and it gives you a route to sail based on your boat polars. Any experience on those with those?
Yeah, I mean, I love it. I think it's really very good. I think PredictWind, their service is fantastic. They've in recent years they've added a lot of features and functionality. They've added like slamming, like how the waves are likely to impact your
Yeah,
boat in addition to the
yeah,
boat polars. They obviously also have I can't remember the name of the service, but they have like the global the information that they send to commercial ships as far as like weather warnings and so forth. PredictWind now tracks into that. I often found that PredictWind, no matter how much I adjusted our polars, maybe it's because I'm a conservative sailor, but it always went too fast for me. It always put my boat like further ahead than I thought. But no, it is really, really we used it a lot. And when we do go and do some more offshore passages, if we're near shore, I don't use it. But if we're doing offshore passages, I think that Predict Wind is very good. If you're thinking about a Predict Wind subscription, and I don't actually have like shares in LuckGrib or anything like that. It's got nothing to do with me. But LuckGrib does also do like the moving meteogram, and it does do some weather routing. But I mean, Predict Wind is it's the number one for a reason. It assimilates a lot of data. It is very, very good. Yeah, I think that it's a very, very valuable resource.
Yeah, and I think that's probably wise advice. It's a valuable resource, but it is a resource. I do think that some people are over reliant on it and take it as the word of God, and follow the weather routing that Predict Wind suggests to them, almost to the letter and to the degree, and to the knot. So I think you're right in saying it is advice. It is a possibility, just as the predictions that they give and the different models that they give. It is one more word of advice, but I would definitely not take it as the word of God and follow it to the letter in routing a boat
Yes.
across the ocean.
Yeah, that is absolutely correct. And I mean, just sort of further to that, Peter, like you said, the advice, because in terms of what we would do is we'd go, okay, we're going to do this. And then, you plug it into Predict Wind. It's like, okay, good. Predict Wind saying, we should do approximately the same thing. So it's that, like, it's an additional resource. So yeah, I think that, yeah, that's really good advice.
Yep. Um, Chris and Jen ask because for this, and but maybe good to re-emphasize again. What month would you say is too late to get to the Canaries from UK or Biscay? It's never really
Yes,
too
I
late, is
asked
it?
you this. um, so look, late, it'll be cold, it'll be uncomfortable. Obviously, you have weather resources. If there's a compelling reason why you can't leave early, then sometimes I know the old saying is, "Oh, you're a sailor, you should never have a schedule," but like we're also people. Um, you should. I mean, Peter and I, we talked about the fact that like you should aim to be sort of, like I think we mentioned sort of you want to get south of Jib, maybe sort of like late October. I think that was sort of what we talked about. But
Yeah,
it's
yeah,
just, I mean, if you think about Biscay, I mean, what Biscay is like 3 days. If you leave it really late, it can be hard to get a comfortable 3-day window at that time of the year, and that's probably the biggest challenge, I would say. And then, if you have to
yeah,
do that passage in hops, because, you've just got like big Atlantic swells, it can be hard to get into ports. It can be hard to get out of ports. Um, so, anything's possible, but I mean, like that was kind of like what Peter and I sort of thought about. I think, we were like, was it, did we mention a date? We did say like once you're south of Jib, you're probably okay, but getting down to Jib,
yeah.
I think it was like end of October, right? Was that? I think that was about what
But
we.
yeah, but end of September. End of
Oh,
September
okay.
more.
Sorry, you're
Yeah,
right. Yes.
yeah,
Okay.
yeah.
So,
End of
yeah,
September. I think
it's
as of September we have the North Atlantic lows coming in more frequently, and closely spaced together. So it's more difficult to find a single window where you can just speed from, the UK or from the Baltic down, to the Canaries. Um, October, as you rightfully mentioned, your present, you have the additional problem. Not only do they get the lows get more closely together, but also you have the temperature. So it gets really cold. We left last year. We left third week of October from Southampton, and we had frost warning on Predictwind. So we had an air temperature of 3 degrees. And I mentioned this to you, Julia, when we were talking in our dry run. I've been on 2 Antarctic expeditions. I had more layers on sitting at the helm on the boat in October, steering from Southampton across the Channel and across Biscay going to the Canaries than I had during my Antarctic expeditions. So you're wet, it's windy, it's difficult, to get your body temperature on. People feel miserable. So probably as an answer to, it's never too late. You can always sail, but is it comfortable? I don't think so. and thinking also that in our flotilla we have cruisers with families, sometimes less experienced sailors, sometimes with kids. My advice would indeed be, try to get somewhere, at the latitude of Gibraltar, somewhere end of September to be comfortable. October is going to be colder and less comfortable, and at my best age, I wouldn't do November or December anymore. That high up. Yeah. Talking about temperatures, another question from Philippe. What temperatures to expect at night during the crossing? Should we think of a winter tent enclosure in the cockpit? Should we have a bimini? Do you remember? It's been a while. I see you thinking, Julia. It's like, oh my
Well,
God, it was
well,
2019. Was it cold?
no, I'm going to answer. It's good actually because you're asking about it in terms of biminis and clothing. Because if it was like actual temperatures, I would struggle. I mean, so the thing about your passage is, you're usually running with the wind, so you're not going to have like that freezing accelerated wind in your face situation. So you're not going to have that. We did not have an enclosure. We do have a bimini. We had a small spray hood. Um, when we started, it was very cold. I mean, it obviously wasn't like I, I'm pretty soft. I like it nice and warm. But I had my beanie on. I had gloves on. And I had my big heavy jacket on. And it honestly seemed like every day it got significantly warmer. And then, we did get to a point in our passage where it was like, we would be sort of, on watch at night, maybe just wearing a sweater because, obviously it is a little cold. So it's definitely pretty warm weather sailing. And, temperature wise, um, if you just want to get warmer, I mean, once you're down to sort of the Cabo Verde, latitude, then, you're very much like just like tropic sailing. So, it's not really cold, especially because, you don't have that, um, you're sailing downwind. So, it's quite comfortable. Yeah. So I don't know what that is in actual temperatures. But you do tend to have like not a lot of variation, in nighttime temps, when you're down in the tropics, it is sort of fairly consistent. So yeah. It's pretty nice. It's pretty nice
Yeah,
sailing, I'm
yeah.
not going to lie.
It also depends a little bit on the boat configuration, whether you have one passage we sailed with the cat, which had a flight deck, which was 4 meters above the water, and it was open. So obviously you catch quite a bit more wind or rain when a squall comes over. Or another boat, we had a center cockpit, so we were very well sheltered from all of the elements. We're sitting very deep in the boat. Some other boats we sail and we're sitting very aft on the boat, at the helm, quite exposed. Um, and there's also a difference, of course, with the air temperature and the chill factor. Even if you sail downwind, it is moisturous. Again, depending on where you sit. If you sit in the center cockpit on a 72-foot boat like we crossed 3 years ago, 4 years ago, we almost didn't get any moisture in the cockpit area itself. But on the last two passages, we were sitting really aft, and you get a bit of the spray from the swell. The air is a bit moisturous, so your clothes get damp, and then you cool off quite quickly. I found myself on those crossings always to have a windbreaker on, even though I had my shorts on. It can get chilly, but it depends on the boat configuration. Um, but definitely a good point for an east to west transatlantic passage is you're going toward warmer temperatures. It's not like the west to east passage where you typically start from St. Martin, you go to Bermuda, and then gradually layer and layer comes on. East to west, one layer after the other comes off. Yeah. Um, However, going from the Canaries down to Cabo Verde, there were some passages where we had full weather gear on, where it was quite windy, quite rainy, wet, humid, where I started to wonder, why am I doing this for? But once I think from Cabo Verde, 14 degrees north, it definitely warms up. Moving on, because the clock is ticking. Um, you covered this maybe quickly again. What differences in weather to expect if you cross early in the season, November to December, compared to late February or March?
I mean, so generally speaking, the Lady Cross, you're going to sort of get more settled conditions, because that sort of pattern is going to shift south. Um, I mean, the main reason why people don't really sort of cross, like, as you can cross into March, but if you sort of cross in March, you arrive in April. By the time you get to the Caribbean in April, a lot of people are like talking about where are you going for hurricane season, and people are sort of starting to get ready to, to sort of move away from the area in some cases. Um, Early season, it's you just can have an influence of, like low pressure systems, tropical waves can sort of push back, as we talked about, like, just because, tropical depressions, just because the storm doesn't have a name, it doesn't mean it's not there. So, and, so I suppose in November, the trade winds can be a little more erratic. As I
Yep.
said, like, December, late December, sort of through January into Feb, that kind of seems to be like where everyone's like, it's like, pretty consistent. It can be like, when you're sitting in the Caribbean, sort of trying to go to a beach somewhere, it can be a little bit frustrating. It's just really, really windy. But yeah, that usually is sort of the peak period. But it's just, you got to look at that band. You got to look at where the Azores high sits, and where the ITCZs, the doldrums, intertropical convergence zones sit. And depending on where you want to be, you just want to make sure, like, obviously, if you do want to go into South America and you want to go early in November, yeah, like I said, you got to be looking out when you're north. You got to be looking out for storms, and you just want to make sure that you're not going to interfere with the ITCZ, which I think by November you should be fine. But sometimes, as I said, these things do lag. So just, yeah, you just sort of need to be cognizant of that. But I mean, if I had to sort of pick a time, it would be December, Feb. But plenty of people go early, and like
Yeah,
have a
because they
fine
want to
time of
be
it.
in the Caribbean early in the season, no?
Yeah, exactly, exactly. So I mean, I think probably November is probably the time. I think if you had a look at the number of boats crossing in any month, I think November, just predominantly because of the arc, but November is probably the busiest time.
Yeah.
And there's plenty of reasons for it. So yeah, so it's a fine time to cross.
Yeah, exactly. Yeah, and the trades definitely are more established as of January, February. But then also something to be to take into consideration: established trades, as you mentioned in your presentation, mean trades of 20 to 25 knots, and add a squall on top of that. You're easily looking at wind speeds of 30, 35 knots with the squalls easily. Um, but it's definitely more moderate November, December, which also means that it is more variable. You can find yourself a couple of days without wind and having to motor, depending on the latitude that you cross. Yeah, I agree. From Monica from Vivere, would it be advisable to cross from Cape Verde to Fernando de Noronha in Brazil in October, or is the weather still too unstable?
I'm not 100% sure where that is in Brazil. Obviously, the Brazil coastline is um, fairly large. I'm going to assume that it's fairly north. You want to just be careful of where the intertropical convergence zone is. I mean, plenty of people cross the doldrums. If you're sailing in the Pacific, it's like you don't have an
Yeah,
option. You have to cross the doldrums.
yeah,
Um, I mean, if you wanted in October, it was October, right? Yeah, so October.
yeah.
You know, if you're going south of Cabo Verde down to Brazil, there's like tropical systems down there are very, very unlikely because your latitude is so low that there's just not enough Coriolis. There's not enough to sort of really generate, like, like a tropical energy. But the convection is still there. The storms from the warm water is still there. I mean, yeah, look, I don't think that October would necessarily be. I guess if you wanted to go early, probably heading south is better. You just, as I said, just you want to be aware of the ITCZ, and you'll probably get, you probably expect sort of some, pretty gnarly thunderstorms. As I said, the closer you, because once you hit. like what I'm talking about, single squalls, plus or minus 10 degrees, or sorry, 10 knots of wind. Um, I mean, you saw in that image that I showed you, like you can just see the area of the ITCZ in the forecast all the time. And, depending on where you're at in like sort of MJO phases and things like that, you could get some very, very intense thunderstorm activity down there. That's sort of that, and those thunderstorms, very, very deep, like planes avoid them, for example. That's how high up into the atmosphere that those systems go. Um, if you did want to do it, you should be really, really cognizant of the tropical hazards outlook. Just sort of trying
Yeah,
to, I would try
because we're
to.
still in the hurricane season, huh?
Yes, you are in the hurricane season, but as you're heading south, like I mean, if you're heading, say, Cabo Verde to Brazil, you're going to be spending most of your time on that journey, like below, say, 10 degrees. And I mean, that's
Yeah, yeah,
generally
yeah,
the
yeah, yeah.
cutoff is even in hurricane season, below 10 degrees. That's usually the insurance cutoff. They're like, you're fine, you can go whatever. I actually think it might be 11 degrees, but so you be fairly south fairly quick. But I mean, you just would have to be cognizant of yeah, convection from the MJO and the intertropical convergence zone. So you wouldn't be dealing with tropical storms, but you could be dealing with some like pretty gnarly like multi-cell thunderstorms. So and a lot of lightning and like microbursts, that kind of thing as a consequence of those. Yeah, so that's what I would be looking out for. You'd be looking out for the intertropical convergence zone, and
Yeah,
the tropical hazards outlook, just to sort of minimize convection.
yeah, 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 yeah. I agree. I agree. There was a discussion on the chat channel about boat pullers, but I think it's a little bit outside of the scope of this webinar now. We can have a chat about this on the WhatsApp group also. Um, cool. I think we've gone through the questions, and I apologize. We've been running a little bit over time, and I blame it on the amount of questions that we had. But it is time to go. Julia, thank you very much for your time. It's been super interesting, and I hope that we can count on you on continuing to be our resident weather lady in our chat. Thanks everyone for contributing through your questions and your active participation. And then I'll see you guys. I think it is next week is our next webinar already. We're gonna have a chat with Steve Neal, who together with Helena runs Noforeignland, who partners up with our team from um, the Finding Dory group in this year's efforts. So everything about Noforeignland, what you wanted to know, and hearing it from the master's voice. Join us then next week. I'll send the link over to you guys in the WhatsApp group. Thanks again, Julia. Well done. I hope you have a lovely time still in Ireland, and we'll be in touch. And thanks, everyone.
Thanks, everyone. See ya. Bye.
Cheers. Thank you, Julia.